Okay, so today I promised you guys we were going to learn how to multiply polynomials by the FOIL method, and it kind of is a little bit easier than I think I implied yesterday, so it's going to take a lot of practice, and believe me, I'll give you lots of practice. So let's take a look at what this is. FOIL just stands for F first, O outer, I inner, L last. So it's for multiplying two binomials, and it's a little shortcut. So if I've got x plus 3 times x plus 2, my first terms are my two x's, okay? And I kind of have those highlighted on your sheet. You guys could highlight those also. Okay? Outer terms is my outermost in the parentheses on each side, so x and 2. My inner terms are my closest terms that are together, my 3 and my x. And L for my last terms are usually my constant terms if I'm doing two binomials generally. So another shorthand method of doing this, and if you look at your paper, I kind of like to make sure that I have a little face. I draw the little face, the little eyes, the little guy. I call him Fred, FOIL Fred. And if you just do FOIL Fred and make sure that you have the face, you get your first, outer, inner, and last terms. And generally, your outer and inner terms are like terms, and you have to combine those. So there it is, that's FOIL. Let's do some examples. Okay, our first one that we come to, s plus 4 times s minus 2. Yesterday we learned the distributive property. You can still use the distributive property. When we're doing two binomials, I will not use the distributive property anymore. I will just use FOIL. That was the distributive property. Okay, when you are squaring two binomials, remember we can't just distribute when there's an addition or subtraction problem. It's only if we're multiplying or dividing. So we actually have to write both terms twice and FOIL or distribute. So we're going to FOIL this one. So this is all color-coded for you. In your notes you'll kind of have to do whatever makes sense to you. I do recommend drawing the lines in, and I can't do that in this program right now. So my first terms are x times x, outer terms are x times negative 4, inner terms are negative 4 times x, and my last terms are negative 4 times negative 4. Remember, what does a negative times a negative equal? So I end up with x squared minus 4x plus 16. My outer and my inner in the middle of FOIL are like terms. I can combine those. My final answer is a quadratic trinomial, x squared minus 8x plus 16. Alright, another example for you. 8m squared minus n times m squared minus 3n. Let's FOIL. Okay, I really recommend drawing in FOIL Fred. Okay, first terms, 8m squared times m squared. Outer terms, 8m squared times 3n, negative 3n. Inner terms, negative n times m squared. And my last terms, negative n times negative 3n. Go ahead and multiply those terms together. This becomes 8m to the 4th. Add my exponents. Negative 24 m squared n. Negative m squared n. Go ahead and rearrange those so it matches our other term. Plus 3n squared. Okay, combine those outer and inner terms in the middle to get 8m to the 4th minus 25m squared n plus 3n squared. Okay, little helpful hint. When you have x plus 5 squared, the base is the whole thing in the parentheses of x plus 5. So remember, that's actually writing it out like this. Okay, it's not just applying it to each thing within the parentheses. That's a big thing. Be aware of that. Okay, pause it and try and get through these. Sorry, I went kind of fast. Okay. So to multiply polynomials with more than 2 terms, we can't FOIL anymore. We have to use the distributive property again, similar to what we used yesterday. Okay, multiply 5x plus 3 by 2x squared plus 10x minus 6. Okay, I'm going to break 5x apart from plus 3 and just distribute it to that whole second term. Distribute it to the whole second term. So I kind of went through on your notes and drew the arrows in for you so you would have a full example of this. Unfortunately, your notes aren't all color-coded. So when you distribute, you just pull that polynomial apart. So basically, I've multiplied 5x through every term of the polynomial, and I've multiplied 3 times every term of the polynomial. You're going to end up with a big polynomial. Look for common terms or like terms, okay? There's no other, so I'm looking for the variable with the same exponent. There's no other x cubed, so that one's going to be alone. I should be writing it in standard form. That means my x cubed is my highest degree. It'll be my first term. X squareds, oh, if I come down here, there's another x squared. I know I'm going to combine those. Here's an x. If I come down here, there's another x. And I've got a constant term at the end. Oh no, what happened to my x terms? Negative 30x and positive 30x is done. Goes away. Okay, so give these a try. Okay, little hint, a polynomial with m terms multiplied by a polynomial with n terms has a product that before simplifying has m times n amount of terms. So the example that we just did a little bit ago, there were 2 terms times 3 terms, so a binomial times a trinomial, 6 terms before combining like terms. So you know that you have distributed or FOILed correctly if you have m times n amount of terms before combining like terms. Okay, where am I ever going to use this in the real world? That's the big question. Okay, here's our application. The width of a rectangular prism is 3 feet less than the height, and the length of the prism is 4 feet more than the height. First hint, write a polynomial that represents the area of the base of a prism. Okay, well, what's the area of a rectangle? Length times width. I have to go up here and look at what's given to me. The width of the rectangle is 3 feet less than the height. Okay, here's h minus 3 for w, h plus 4 for length. We haven't really got to there yet, but okay, so I'm using this h term, but it's a common variable in both polynomials. So go ahead and FOIL that. I'm not showing that step, but you should look at the FOIL process for that, combining my outer and inner terms here. To end up, the area of that would be h squared plus h minus 12. Depending on what that height is, the area is represented by h squared plus h minus 12. Well, part B says find the area of the base when the height. So 5 squared plus 5 minus 12. You can use a calculator, but really 5 squared is 25, plus 5 is 30, minus 12 is 18. Okay, then go back and answer the final question. 18 square feet. We're dealing with area. Okay, that does it for the notes. Here's your quiz. Take your time, talk in your group, use whatever necessary in order to get through that quiz and solve the application at the end.